Okay, so yeah, we are recording now. So this is chapter 2, which is polynomial and rational functions, and section 2.1 is on quadratic functions and models. So if everybody in block 2, you want to give a shout out to the people that are not here?
Yeah, go.
Okay.
Hi, Jack.
Okay.
Miss you, Dimmick.
All right. So at this point,
I'm Jewish. Kosher too. I miss Jack.
please don't make me stop this video and start again. All right, are we ready to go?
Tommy, Jack, and Dimmick, and everyone else too.
Enough of the shout out, Billy. Okay. All right, so 2.1, quadratic functions and models. So some examples of polynomial functions might be something like f of x equals 3x to the fifth minus 2x plus 1. That would be an example of a polynomial function. Same thing here. If I had f of x equaling 7 halves x squared plus 3x. That would be an example of a polynomial function. F of x equaling 6 would be an example of a polynomial function. All right, in general, a polynomial function of x with degree n it is written f of x equaling a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus a sub n minus 2 x to the n minus 2 and so on, all the way down to a sub 1x plus a sub 0. All right, don't let this big long expression, throw you off or anything or confuse you. It's basically just a notational device for us to be able to talk about polynomials in general. The a's that you see are all the coefficients on your terms, all right? And the n would be your your degree, right, on your leading term. All right, so all of the a values are real numbers. A sub n is not allowed to equal 0. That's our leading one, because otherwise, because we want to be able to say that this is degree n, and we can't if the leading coefficient is something other than 0.
Is that n minus 1 or is it just n1?
That's n minus 1, then n minus 2, and so on. And those are just subscripts, so we're not really subtracting, from the coefficient. It's just, again, it's just a way of naming the different coefficients. All right, so let's talk about how to classify polynomials by degree. So let's take a look at a few different polynomials. If we had f of x equaling, let's say 5, and f of x equaling, let's say 3x minus 1, and let's say we had f of x equaling 4x squared minus 6x plus 9. If I'm giving you all these with different degrees, right? Okay, so for this first one, this one is really, think of this as x to the 0, right? X to the 0 is equal to 1. So if you see just a constant like this, then we call it a constant function. All right, why is it called a constant function? Because if you were to graph the function f of x equals 5, what would it look like? Well, all lines are straight. Horizontal line, where the value of the function never changes. It's always at an even height of 5. So that's a constant function. What do we call this function here that's a degree 1? So this one here, I'm going to try and write degree. This first one's degree 0, and we call it a constant function. This one's a degree 1, and we call it what? It's not a monomial. Monomial would mean one term, and this has 2 terms. Besides, that's classifying by the number of terms, and we want to classify it by degree. Starts with an L. Linear. So if it's a degree 1, we're going to say it's a linear function. That's degree 1. What if it's a degree 2, like this one? Degree 2 function. Quadratic. Starts with a Q. Quadratic. Next one, degree 3, is what? Cubic. And what about a degree 4? It is. It's quartic. That's quartic. All right. Degree 5 is quintic and so on, but you don't need to know all that. All right. But today our focus is on, oh boy. Today our focus is on degree 2 polynomial functions. This section is focusing exclusively on quadratic functions. So let's take a closer look at a quadratic function. All right, this quadratic function here, if we let a, b, and c be real numbers with a not equal to 0, then f of x equaling ax squared plus bx plus c is a quadratic function. All right. I am. All right, the graph of a quadratic function is a U-shaped parabola. And there's so many really awesome real-life examples of quadratic functions. For example, the path of a golf ball. When you hit a golf ball, the path of anything that's tossed, hit, spiked, whatever, is going to have a parabola associated with it. The reflector inside of a flashlight. Did you know that that's why flashlights' beams go straight forward and not like all over the place? Because of the properties of the parabola on the mirror that's right behind the bulb. A little demonstration. Let's say here's your flashlight, and here's your bulb right here, right? You know that the light is coming off all different directions from that bulb, right? But there is a parabola-shaped mirror. I'm just doing a cross-section of your flashlight, right? But one of the properties of parabolas says that every time you have this beam, it's going to come straight off. So every time it hits the parabola, it comes straight off like this. So that's why the beam of a flashlight is always going in one direction. Does that make sense? Okay, anyway, cool example of quadratic functions. So when you graph a parabola, we did say that it is a U shape, right? If you graph a quadratic function, and when you do that, there is symmetry associated with your parabola. There's going to be this line, this axis of symmetry that shows that your graph has been split up into two mirror images, okay? The place where the axis of symmetry actually crosses your parabola is called the vertex. Good. So the vertex is the point where the axis intersects the parabola. If your leading coefficient is positive, then the parabola opens up. If the leading coefficient is negative, then the parabola opens down. The leading coefficient is the a value, right, in ax squared plus bx plus c. So if the a is positive, then the parabola opens up. If the a is negative, it opens down.
Is the A value of what?
Billy.
Wait, can I give a quick shout out to Tom? I don't want to give a shout out.
No, Billy.
I forgot
You may not.
people I want to say hi to.
Okay, so at this point, would you grab your, grab your graphing grab your graphing calculators, please.
Alright, so wait, the A value of what equation? The leading coefficient is the A value of AX.
So if your leading coefficient, that's the a in ax squared plus bx plus c, that leading coefficient is the a. If a is greater than 0, your parabola opens up. If a is less than 0, your parabola opens down. All right, so on your graphing calculator, I would like you to graph just the basic parent function for the quadratic, so that's just x squared. So if you would graph that, please. There's y equals x squared. and I would like you to also graph y equals, let's graph y equals 2x squared on the same page. So pushing tab, I want 2 times x squared. And what happens to the graph? All right, the graph gets narrower. Why does the graph get narrower? Billy,
Horizontal compression, right?
is it because of a horizontal compression?
Yeah.
Andrew,
Because that you don't need this big numbers to get the same Y value from each.
okay, but is it, I guess it's looking narrower for one of two reasons. You need to decide which. Is it because it's being horizontally compressed? Is that why it's narrower, or is it because it's being vertically stretched? It is vertically stretched because all of our y values, remember these were our y values previously, but we're going to multiply all of them by 2. So all of our y values are 2 times as high. Each of your new y values is going to be double your original y values, right? X squared being your original y values. Okay, so if I add to this graph, let's put another one. How about 1/3? And I'm going to do, let's see, a fraction template here, so I can do 1/3 like that, and then times x squared. All right, we don't say vertically stretched. Vertically stretched means it's being pulled like this, right? People have, so it's vertically compressed. In other words, it's been squished. All of our y values, right? All of our previous y values are now only 1/3 as high as they were. So that we would say is a vertical compression. All right. So we compared some graphs. Let's see. So recall from section 1.7, how does f of x plus or minus c differ from the f of x? Billy?
The plus or minus C is the vertical shift.
Okay. So with this, if we're adding a number after the function itself, this is a vertical shift up C or down C, depending on whether it was a plus C or a minus C. Agreed? But it's a vertical shift. So if we had f of x equaling x squared, how is that going to compare to f of x equaling x squared minus 4? How are those two graphs going to look different, Billy?
The second f of x, or if I call it g of x, is going to be shifted down 4 units compared to f.
All right, so yeah, sure, I can call this g of x here. So g of x is going to look just like f of x, except it's shifted down 4 units. So in my graph, if my original function f of x looks like this, my function g of x is going to be 4 units down. It's going to look something like that, right? Agreed? All right. Okay, now what about this? How about f of x plus c or f of x minus c differ from f of x? So how does f of x equaling x squared differ from, let's say, g of x equaling x plus 3 quantity squared?
Horizontal.
Megan? If it's plus, it's shift left. Let's test that. Let's grab the calculator. I'm going to go to a new page in this document, adding a new graphs page. I'm typing in my x squared. And now I want to add, what did I say, x plus 3? Okay, so if I'm going to do parentheses, x plus 3, close parentheses, and I want to square that. Has it been shifted 3 units to the left? Are we okay with this? All right. So back in our notes, we're going to say if you have an x plus c or an x minus c before you plug it into the function itself, then that is going to give you a shift right or left. Agreed? This one was a shift left 3 units. If I have h of x equaling x minus 4 quantity squared, that would be a shift what? Shift right 4 units. Are we okay with this? All right. So if you were to graph this one, your prediction, what would the graph be, and where would the vertex be? Ryan, who has his hand up.
Okay, it would go up 2 units and to the right 3 units.
All right, it would be to the right 3 and up 2. Now, let's back up for a second. If I'm asking you about the parent function f of x equaling x squared, which you know looks like this. By the way, just so you are clear on this, if I ask you to plot this on graph paper, you know that this graph of x squared is going to go through 0, 0, 1, 1. What would be the next point? 2, 4, right? 3, 9, and so on. Over here, I would have what? Negative 1, 1, and over here I would have negative 2, 4, and so on. All right, so what's the vertex for this graph? All right, so this one has a vertex at 0, 0, right? That's the vertex right there. So what will the vertex be of this graph? 3, 2? Because I want to go to the right 3 and up 2. So the vertex would be 3, 2. Are we okay with this? All right, so standard form, which I will, I think, sometimes call vertex form, but standard form, according to your book, is f of x equaling a times x minus h quantity squared plus k, where the leading coefficient a is not equal to 0. All right? They call this standard form because you're able to just pick off what the vertex is just by looking, because whatever's being subtracted from the x is going to be the x coordinate of your vertex. Whatever's added on at the end is going to be your y coordinate of your vertex.
So is it only saying that it can't be 0, it doesn't have any other?
The a is your leading coefficient, and if it was equal to 0, we would no longer have a quadratic function. We would just have a constant function.
Which is just a constant.
Correct. All right, so let's give some examples. So let's say we had f of x equaling, let's say, 3x minus 2 quantity squared minus 6. I would like you to tell me, does this open up or down? And I would like you to tell me what the vertex is. And I would like you to tell me what is the axis of symmetry. Ryan.
So it opens up since the first is positive.
Okay, because the a is positive.
The vertex would be 2, -6.
Do people agree with that? 2, -6? God bless you.
Yeah.
And the axis of symmetry?
Wouldn't it be y is equal to -6, or x is equal to -6, or 2?
Which?
2.
X equals 2?
Yeah.
Do people agree with that?
Yeah.
So if we were to graph this, 2, -6 is right here. We know it opens up, so it's looking something like this. Right? It's going to be a pretty narrow, right, because it's been vertically stretched. Right? So instead of it going over 1, up 1 to get to another point, I'd go to the right 1, up 3, and so on. But yes, this line right here is my axis of symmetry, and that is the line x equals 2. So that is our axis. Are we okay with this? All right, let's try one more of those. What if I said f of x equaling -3 times x plus 1 quantity squared plus 4. Tell me about the axis. Tell me, does it open up or down? Give me the vertex. What do you think? I'm going to start calling on people who have not helped me out yet today. Andrew, tell me what you can about this. It is indeed. Opens down. Okay. Exactly. I need an equation. Axis is a line. So x equals -1 is the equation of my axis of symmetry. And what's the vertex going to be? Do people agree? -1, 4.
Yeah.
All right. We know it's opening down because this leading coefficient, our a, is less than 0. All right. So what else? Okay, excuse me. To graph a parabola, begin by writing the quadratic function in standard form using the process of completing the square. Have you learned completing the square already? Did we talk about that back in the appendix?
Or it didn't suck. That.
Oh, okay. Well, that's better clarification there. Okay. At this point, I am going to give you a gift. Can you pass those out to everybody, please? All right, on this first gift, which I'm actually calling gift 2.1b just to confuse you. On gift 2.1b, the directions are asking you to solve an equation, and we're also going to be trying to solve by completing the square. All right? All right, so number 1 on this gift B. This is gift B. Number 1, it says solve 2x squared minus 16 equals 0. So what would you do to solve that?
Add 16 to both sides.
Add 16.
Divide by 2.
Divide by 2. Take the square root. What do I need to do when I take the square root of both sides? Plus or minus. So I really have x equaling plus or minus square root of 8, which is, can I simplify that?
2 times 4.
So square root of 4 times square root of 2. So I get plus or minus 2 square root of 2. Are we okay with this? Questions on this one?
I was right at this.
How about number 2? Number 2 from the gift says,
I don't know why I'm thinking this. I was thinking, okay, I was going to do x plus 4, x minus 4. I forgot about the 2 before the
right, the 2 is not a perfect square. So you do not have a difference of 2 perfect squares here. Okay, so here, what should be our first step in solving number 2, Miriam? What should we do first here? Distribute the 3? Distribute the square. Oh, you want to do like x minus 4 times x minus 4? And do FOIL? You could do FOIL, but I think that hang on a second, guys. Shh. I think if you do use FOIL, you're going to just be making life a little bit more difficult than it needs to be. Because really, if you already have a binomial squared, that's a pretty powerful thing in solving. That's a pretty good place to be in. So what would we do to solve this if we don't want to destroy that binomial squared? Molly? All right, let's divide both sides by 3 as our first step. So I'm going to have x minus 4 quantity squared equaling 9. Then what can I do? Do I want to use FOIL now? No. I want to take the square root. Take the square root of both sides, and I get what?
x minus 4 equals 3.
Plus or minus 3. So that means I can add 4 to both sides. So I get x equaling 4 plus or minus 3. So what are my 2 solutions to this equation? All right, 4 plus 3 is 7. 4 minus 3 is 1. So these are my 2 solutions. I could plug them both in for x, one at a time, of course, and see that they both work. Are we okay with this? All right. Number 3. What needs to be added to the expression below to make a perfect square trinomial? Well, let's back up for a second. X squared minus, I don't want to give any of these away. Let's say x squared minus 12x plus 36. This is an example of a perfect square trinomial. This is an example of a perfect square trinomial because, why am I calling it a perfect square trinomial? Because it can be rewritten as a binomial squared. What would the binomial be that I could square in order to get this? Jasmine? x minus 6, right? X minus 6 quantity squared would be this one. Let's try one more. How about x squared plus 4x plus 4? That's a perfect square trinomial because it can be rewritten as what binomial squared? X plus 2. So what would be a pattern? What's the relationship between this number here and this number here? So if I say, for example, x squared minus 6x, this is, we're on example 3a right now from your gift. If I have x squared minus 6x plus what would I need to have right here in order to create a perfect square trinomial? Ryan, where'd you get 9 from?
Well, because expect like a pattern, 6 plus 6 equals 12, 2 plus 2 equals 4, 3 plus 3 equals 6.
So what can I do? What can I do to the negative 6? Divide by 2, and then square that. All right, so I take negative 6 divided by 2. Half of negative 6 is negative 3. Squared is 9. And by doing that, I will have just created a perfect square trinomial. So what should my binomial be? X minus 3 quantity squared. Are we okay with this? All right, what about the 3b? 3b is x squared plus 18x. What do I need to add right here so I can create a perfect square trinomial? Megan. 81. How'd you get 81? All right, so I take half of 18 is 9, and 9 squared is 81. And then what's our binomial going to be here, Harrison?
It's going to be x plus 9 squared.
X plus 9 quantity squared. By the way, hint, this number here, when you take half, is always going to be the number that shows up here, right? Dan. All right, so let's take a look at number. All right, you want the twist. Okay, so
No, I want to make
let's.
sure I'm ready for it. I don't want to just like be doing my home alone, and all of a sudden.
Well, let's just say let's just say, Dan, that there's a lot in this section 2.1, so there's a lot more ground that we can cover. All right, so let's take a look at number 4. X squared minus 8x plus 16 equals 25. Is the left side already a perfect square trinomial? Okay, so rewrite it as a binomial squared and solve that equation. Tim, how did you rewrite that left side? X plus 4? Do people agree? X minus 4? So if I have x minus 4 quantity squared, then what do we do? Billy, take the square root. Don't forget the plus or minus. So I get x minus 4 equaling plus or minus 5. Agreed? Did you get 2 solutions?
Yes.
And your 2 solutions are?
-1 and
All right. Are we okay with this? Okay, so now, if I ask you to go down to number 5, where it says solve by completing the square. 2x squared plus 20x minus 7 equals 0, right? So, first of all, is this left side a perfect square trinomial? No. Well, there's a couple reasons why. First main reason is it's not a perfect square trinomial because this leading coefficient is not a 1, and it's got to be a 1. So what are we going to do about that? Okay, so if we divide everything by 2, do we want to do, sure. Okay, so if we divide everything by 2, we'll go with that for right now. X squared plus 10x minus 7 halves equals 0. Is this left side now a perfect square trinomial? No. So here's our process of completing the square, because we're going to try and create a perfect square trinomial. Billy.
You add 7/2 to both sides.
All right. Add 7/2 to both sides. I'm going to leave a little room to complete the square. And then what number would I like to have right here to form a 25? Half of 10 is 5. Square that is 25, right? So now my left, oh, but I just added 25 to the left side. Billy. Got to add it to the right side also to keep the equation in balance. So now I have x plus what? X plus 5, quantity squared equaling, what is this going to be?
We just break it into 28.5.
I'm going to write this as 50 over 2. So I'm going to get 57 over 2. I'm a fraction person. And then we take the square root of both sides, plus or minus, and I get x plus 5 equaling plus or minus square root of 57 halves. Does that look right? And then I'm going to subtract 5 from both sides and call it done. I keep doing that. Square root of 57 over 2. All right, we won't worry about simplifying the radical for right now. Are we okay with this? All right, so I'm going to let you work on 5b on your own some other time. What is vertex form for a quadratic function? Well, I'm calling it vertex form on here. It's standard form is what we talked about. So now let's talk about number 7. It says write the function in vertex form / standard form and identify the vertex. So if we're looking at, this is 7a, it says f of x equaling x squared plus 12x minus 5. It's just the standard form, right? That's just the standard form, Dan. All right, we're on to 7a. So if I want to write this in standard form, which you know is a times x minus h quantity squared plus k, that means I'm trying to get a binomial squared. How do we get a binomial squared? It's called completing the square. So we need to complete the square on this. Do I have a leading coefficient of a 1?
Yes.
Yes, I do. Is this already a perfect square trinomial? No. So what we're going to need to do is, I've got x squared plus 12x. I'm going to leave some room, and I'm going to put that minus 5 right out here. Does that make sense? I'm trying to get this into this form. All right. So right here, what number would I like to add to create a perfect square trinomial? 36. Take half of 12 is 6. Square that is 36. But if I add 36, I just changed my function. So I need to undo that because I don't want to mess with the left side. I still want my left side to just be f of x, right? I don't want f of x plus 36. So I'm going to subtract 36 over here on the same side. I'm adding 36 and subtracting 36 to the same side of the equation to keep my, or I'm adding 36 to the function and subtracting 36 from the function to keep the function the same.
Would it be okay if we just did minus 41?
So we're not done yet. So we're going to write in our function now, f of x equaling, what are we going to have quantity squared? X plus 6 quantity squared, and then minus 41. So this is our function. It is now in this standard form, and we can identify the vertex is what? 6? Is it 6 or negative 6? Negative 6, negative 41. Are we okay with this? All right. Okay, what about the 7b? So if I have f of x equaling 4x squared minus 16x plus 9, and I want to put this into standard form. Do I have a leading coefficient of 1? No. So what are we going to do? I hear divide. I hear factor out 4. Well, here's the thing. We do not want to divide by 4 because if we do, we're going to have f of x over 4 over here. We don't want an f of x over 4. We just want f of x. So we are going to factor a 4 out, but only from these first two terms. This plus 9, we're just going to slide that over. It's still part of our function, but we're going to kind of ignore it for right now. So I'm going to factor a 4 out of just those first two terms. So what am I going to have? X squared, then what? Minus 4. I'm only factoring out a 4. Even though I could factor out a 4x, I don't want to do that. I just want to factor out a 4. So minus 4x, agreed? Then what would I need to add right here to make this little parentheses be a perfect square trinomial? So I want to take half of the negative 4, which is negative 2, and square it and get 4. Are we agreeing? But I just changed the function by adding that 4.
Subtract 4 from 9.
Do I want to subtract 4 over here? Ryan gets a Pez. Ryan says it's going to have to be 16. Ryan, explain why it's going to have to be 16 over here. Yeah, if I put a 4 in this parentheses, where everything in this parentheses is getting multiplied by this 4, the net effect on the function is I really added 16 to the function. So to undo it, I need to subtract 16. Does that make sense? And boy, Ryan, I hope I have a Pez for you. I do. It's Eeyore.
Jack, I love you.
All right. So if we subtract 16, we can now rewrite our function as f of x equaling 4. By the way, that 4 is important. That's our a value, right, in our formula, times x what? Minus 2. Remember, it's this number right here that goes in here, right? X minus 2, quantity squared, minus 7. And what's the vertex? And what's the vertex going to be? 2, negative 7. Are we okay with this? All right. Okay, so all right, we already talked about perfect square trinomials. You're all good with that. We did this. You're good with that. Okay, so let's jump to this. To find the x-intercepts, we're switching gears now, not talking about completing the square anymore. Gentlemen, focus. To find the x-intercepts of f of x equaling ax squared plus bx plus c, you must solve the equation ax squared plus bx plus c equals 0. You can try factoring, but if that does not work, then you're going to need to use quadratic formula, which I know you all know. All right? Okay, so again, if I'm asking you to find the x-intercepts, that means we're trying to find the place where a parabola crosses the x-axis. You with me? Okay. The parabola may cross in two places, so you'll have two x-intercepts. It may cross in just one place where the vertex is, so we'll only have one x-intercept, or it may be, completely above the x-axis, or if it opens down, it might be completely below the x-axis. So in this case, how many x-intercepts are there? 0 x-intercepts. All right, so let's take a look at this example. You're going to find the vertex, the x-intercepts, and the y-intercept, and sketch the graph of f of x equaling negative x squared minus 4x plus 21. At this point, I am going to turn off or pause the video while you are working on this. Okay, so for this graph, you've had some time to work on it, and what did you get for the standard form? Did you factor out a negative 1? Yes? So if you factored out a negative 1 just from the x squared and the 4x, and you left a little room, and you left the plus 21 out here like this, agreed? So then what did you have to add right here to create a perfect square trinomial? Billy? 4. Half of 4 is 2. 2 squared is 4. So then what do I need to do out here? Is that going to be a minus 4 out here or plus 4? But by putting a 4 here, everything here has to get multiplied by this negative 1. So I really subtracted 4 from the function. So to undo that, I have to add 4. Do we agree with that? All right, that means our function in standard form is negative 1 times x plus 2 quantity squared plus 25. Are we agreeing with this? Okay. And that means that your vertex is what? Negative 225. And your y, oh, what's your y-intercept? Y-intercept? 21. You got to plug in zeros. Plug in zeros for the x's. So the y-intercept is equal to 21. Correct? Andrew? By adding 4 here, everything here has to get multiplied by this negative 1. So that means by putting a 4 here, I really subtracted 4 from the function. So I need to undo that by adding 4. Ryan?
I put the 0 in the last, I put it, you know how we got to...
In here? Yeah, that's fine. You should still have gotten 21. Okay, so you can plug in 0 here or plug in zeros here. Either one. All right, and what about solving to find the, what are we trying to find? X-intercepts. Negative 3 and 7. Do people agree?
Yes.
How did you get that, Harrison? Did you set this one equal to 0, or did you set this equal to standard form? Standard form. Okay, so if I have 0 equals negative 1 times x plus 2 quantity squared plus 25, I can subtract 25 from both sides. I get negative 25 equaling negative 1 times x plus 2 quantity squared. I can divide both sides by negative 1. So I get 25 equaling x plus 2 quantity squared. Take the square root of both sides. Don't forget that plus or minus. So I get plus or minus 5 equaling x plus 2. Subtract 2. And I get negative 2 plus or minus 5 as my solutions. So negative 2 plus 5 is 3. And negative 2 minus 5 is negative 7. Did you get these as your x-intercepts?
That's how I got 7 and 9.
Don't know how that would have happened.
My 2 wasn't. Oh, you didn't subtract it over, did you? I didn't subtract 2 over.
Gotcha. Okay, so at this point, let's keep going. Is this problem on your gift? Okay, so let's do this one. Write the standard form of the equation of the parabola whose vertex is negative 4, 11, and that passes through negative 6, 15. So again, I would remind you of standard form. And if we know that the vertex is negative 4, 11, that means I can plug in negative 4 for what in this equation? H. And the 11 goes in for K. All right, so if I do that, I get f of x equaling a times x minus a negative 4 is x plus 4. Agreed? Quantity squared plus 11. And that's our equation, except we don't know what this a value is yet. How are we going to find the a value, Tim?
Plug in one of these things.
Well, we're going to plug in the negative 6 for x, and the 15 is our y, but that means that's our f of x. So if we do that, we get 15 equals a times negative 6 plus 4 quantity squared plus 11. Would you take a minute, please, and solve for a? Okay, so if we are trying to work this out here, the negative 6 plus 4 is a negative 2. So I have negative 2 squared is a positive 4. So I really have 4 times a plus 11 equals 15. I'm going to subtract 11 from both sides. So I get 4 equals 4a, divide by 4, and I do get a equals 1. Not a very interesting a value for this particular problem. Well, but our function now is fx equaling 1 times x plus 4 quantity squared plus 11. 1 being optional. Are we okay with this? All right, anything other than 1 would not be optional to include. Okay, so let's move on to the next question. Choose the correct answer. A parabola that opens up has a minimum value or a maximum value. Which one should I circle? Minimum value or maximum? If the parabola opens up, it's going to have a minimum value. There is a lowest value that it's going to have. Whoops, that's not what I want to circle. Minimum value. A parabola that opens down is going to have a what? Maximum value, right? All right. Okay, so the maximum or the minimum value is the y-coordinate of the vertex. So if I ask you for find the minimum or maximum value, I'm only asking for the y-coordinate of the vertex, not the whole vertex. All right. Okay, I'm skipping that. All right, so let's take a look at this example. Is this one on your gift? Okay, the height y in feet of a ball thrown by a child is given by y equals negative 1/8 x squared plus x plus 4, where x is the horizontal distance in feet from where the ball is thrown. How high? How high is the ball when x is at its maximum height?
You're thinking, all right, so it's got to be a negative because the parabola opens down.
All right, the parabola is opening down, which means that the child is throwing the ball and it's taking some kind of a path that looks like this, right? The ball's going up and then gravity's pulling it down in a nice parabola. Agreed? So you are trying to find what point. To find its maximum height, you need to find the what? Billy?
Vertex.
Vertex. So we're trying to find this vertex here. And how are we going to go about finding the vertex?
Complete that square, though.
Completing the square. Well, guess what? Is this going to be a big mess? Yes, it will. This is going to be kind of a messy one. So let's find the vertex in a different way. So if I back up a second, it says to find, no, not the graphing calculator yet. To find the vertex if it's in, I guess your book might refer to this as general form.
General form?
Right? If it's ax squared plus bx plus c. To find the vertex, you can use the formula x equals negative b over 2a. This really gives you the x coordinates of the vertex, and if the problem is really messy, like this parabola with this child, then you're going to want to use this formula instead of trying to complete the square. So if we do negative b over 2a, we will get the x coordinate of the vertex. All right, and then how do we find the y coordinate? We would just plug that value in for x, right?
So once we get x, we plug it in.
Right, so if I give you a sample problem, so let's say f of x equals 2x squared minus 8x plus 5. And I'm trying to find the vertex. I could complete the square, or I can use this negative b over 2a formula. And so if I do negative b over 2a, you know that this is your a, negative 8 is your b, 5 is your c. You with me?
Yeah.
So what am I going to have?
X equals 2.
Because you got opposite of negative 8 over 2 times 2. Is that right? So I'm getting 8 over 4 is 2. So that tells me that my vertex is 2 comma something. Agreed? So to find that y coordinate, we need to do what? Plug in 2 here, and here. So I'll get 2 times 2 squared minus 8 times 2 plus 5, and we get what? 3 or negative 3? Negative 3 is going to be my y coordinate. Are we okay with this? So that's what you need to do here to find the vertex. I think that's going to be a lot easier than doing the completing the square. So go ahead and do that at this point. Okay, so with this problem, if we want to do negative b over 2a, did you do opposite of 1 over 2 times a negative 1/8? Does that look right?
Yes.
So I get a negative 1 over negative 1/4. And that's the same as negative 1 times a negative 4 over 1, which is a positive 4. Everybody agree?
Yeah.
So that's telling me that this vertex here is the ordered pair 4, comma, something. And so how high is the ball when x is at its maximum? I have to plug the 4 in. Did you plug in 4 for x here and here? Yes? And so we get negative 1/8 times 4 squared plus 4 plus 4. I'm getting negative 1/8 times 16 plus 8. Is that negative 2 plus 8 is 6?
Yep.
All right, so that means that the answer to the question is the ball reaches a height of 6 feet. Correct?
Wow, that's a very sad throw.
Well, it's a small child. All right, so here is your homework from this section.
That is
Whoa, I hate
Stop the hating.
that is a sad.
All right.
You didn't even throw it.
Please tell me you're not going to make the English.
Save.